Okay, stats. Starting chapter 10 today. I'm only going to get like partway through these notes, and then we'll do a part B tomorrow when I'm in class. But we are starting the section on, or chapter 10 is kind of talking about linear correlation. So, like two different variables that are happening or that are going on at the same time, and they want to know if it has a linear relationship. So, like things that could happen for a linear relationship look like this. So either as one is increasing or going up, the other one is also going up, or as one is increasing, the other one is decreasing, kind of like this one's doing here. And I'll give you some examples of that. So, yeah, they can either have an increasing relationship or an increasing decreasing relationship, but then you could have two variables that have no relationship between each other, or two variables that are related in some other way besides linear. So this would be like a quadratic relationship. So that could be like the distance traveled, dropping something off a cliff or whatever. That would be more of a parabolic or a quadratic relationship, rather than linear. So let's talk about some of the stuff here up here at the top. A correlation exists between two variables when the value of one variable are somehow associated with the values of the other variable. Now, a lot of times you can have a correlation. So we just said a correlation doesn't necessarily have to be linear. It could be that there is a quadratic correlation. But then we get down here to a linear correlation exists between two variables when there is a correlation and the plotted points of paired data result in a straight line. So as one increases, the other one increases, or as one increases, the other one decreases, etc. Right? Now, let's see. Like an example of this would be, like let's say in the summertime. So as summer progresses, or as like the days in the year progress, the number of ice cream sales increases. So that would be kind of a linear relationship, in that it's going up. I'm trying to think. Or another example would be, instead of summer and ice cream, let's say like age versus height. So typically the older you get, the taller you are. Not in every case, but that's kind of a linear relationship. A case where something goes up, but then as it increases, the other one decreases. I don't know. Let's say, okay, this is a really stupid example. Let's go off of age again. So as you age, or as your age gets older, this is your hearing. I don't know. Not in every case does somebody lose their hearing, but as you get older and older and older, maybe this is some data of some people in a nursing home or something where the older they are, their hearing is starting to decrease. I don't know. Maybe that would be a linear correlation. So something of that nature. Then we have things that are not correlated at all, and then we have things that are correlated but not linear. Okay. A linear correlation has this is called a correlation coefficient, and that is called R. They label the correlation coefficient with an R value, and R lives somewhere between -1 and 1 always. So whatever your data is, whatever two things you're comparing, it will spit out, or like if you do this with an equation, it'll spit out a value for R, and R will always be a number that lives between -1 and 1. And here's how it works: -1 and 1, with 0 being in the middle. The stronger the correlation is, the closer those values are to -1 and 1. Okay, this is a weak relationship. Okay, so this would be like a strong relationship in the positive direction. So it would look a lot like this example, and this would be a strong negative relationship. So this would look like this example. A weak relationship would be a number close to 0. So like these values right here would probably have, like this one has let me get rid of some of this stuff here. This one has an R value of -0.97, which is a number that's really, really, really close to -1, because those are really strong negative related. This has an R value of 0.86 almost, which is really close to a positive 1, because those values are pretty close to being linear. Here we have an R value of 0.074, which is really, really close to 0. That means it has a weak relationship, in that, like, those dots are not anything. And then a nonlinear relationship, that R value might be like, it's not going to be close to -1 or 1, but it's, I don't know, kind of in the middle here. 0.33 is not a great linear relationship, because it's has a different relationship, so like quadratic or cubic or something like that. So that's kind of how that breaks down. On your homework assignment, I know, like number 3, I think it is, you're having to match the R value with the graph. Okay, and so I'm going to have you guys do that one for homework for tomorrow, but we'll go through that here in just a second. Linear correlation coefficient R, okay, is going to take into consideration your X values and your Y values. So you'll have 2 sets of data. So like we were talking about here, like age and height. Okay, so these would be your X's, these would be your Y's, and you're taking that into consideration, and you're calculating, and you're spitting out what the R value is. Okay, here, if you go down to our first example, which is on the second page, this data we're going to be finding an R value for, and it's kind of a pain in the butt, actually. They give us some data here, and these are our X's and these are our Y's, and we're trying to find the value of R. Okay, we can do that by using technology, which I'm going to show you how to do tomorrow, because I going back and forth from my iPad to computer is just weird. But we're going to do example 2, part A of it, which is like part of the icky stuff of calculating R. Okay. If you go to the top of the second page, it says requirements in order to be able to use a linear correlation. The sample pair of data has to be from a random sample of quantitative data. So we can't have categories like blue eyes, brown eyes, green eyes, whatever. We have to have quantities, which is numbers, okay? Visual examination of the scatter plot must confirm that they're approximately a straight line pattern. So we can see, like up here, we had, obviously this is not a straight line pattern, so we're not even going to waste our time probably calculating the R value, because it's going to be so yucky. And anyway, so we're not going to waste our time. And then number 3, because results can be strongly affected by the presence of outliers, any outliers need to be removed. You know, like if I have this line going on and I have one outlier that's over here, it's going to screw up my line and make it go this way when the majority of my data is living here. So we want to make sure we remove any outliers that we can see from the graph before we begin calculating the R value, okay? All right, so there's that stuff. One more thing that I want to talk about before we actually calculate it in example 2, and it is that. I'm going to put a little star here. I think we talk about this tomorrow. So put this somewhere on your paper and make sure you mark it really big. That correlation does not imply causation. Okay, so, and I know we've talked about this before. I think you even had a question like this on your test when we had, like, I don't know, when we were in chapter 4 or something, maybe. Correlation does not imply causation. So just because 2 things are related does not mean that one causes the other one to happen. Okay, so like in the summer, you know, maybe instead we're graphing like ice cream consumption. So ice cream sales, let's say ice cream sales and drownings. Okay, so as the sale of ice cream goes up, the number of drownings goes up. Does that mean that eating ice cream causes me to, or makes me at a higher chance of drowning? Which is what a lot of people think. That's where the rumor comes into play that you have to like wait an hour after you eat to go swimming. Like that's a thing. Like that's where that rumor came from, was that they thought that eating things cause you to drown. And that's not necessarily true. The underlying factor is that like hey, you eat more ice cream in the summer and more people drowned in the summer. So just because those two things are related and they have like a linear relationship does not mean that one causes the other one to happen. Okay, so I know that they will ask you some questions like that on your homework, and so beware of that. Just because two things are related doesn't mean that one causes the other one. Okay, all right, let's go down and we're going to do this data, and we're going to plug it into example 2 into this. This formula looks really ugly and nasty, but it's actually not as bad as you think. This second formula for calculating R, because they give us two options for calculating R. They give us this equation here, and then they give us this one. Actually, the top one, as ugly as it looks, is actually easier to do stuff with. Okay, this one involves more icky stuff. Okay, so we're going to do this top one, and then I will tell you what I want you to do for homework. Okay, so let's just talk about the things that we are comparing. Okay, we're talking about chocolate consumption. So the amount of chocolate you are eating, right? And then Nobel Prize winners. So Nobel laureates is what they're called. We're talking about people who have won Nobel Prizes and chocolate consumption. So I don't know what these units are in. It doesn't say. So I don't know however many pounds of chocolate they've consumed in a year or something. I have no idea. And then how many Nobel Prize winners there are. Okay. So we're trying to see if there's a relationship between the two. And this seems kind of silly because it's like those two should not be related to each other. But we're going to test it and see. I don't know. To see whether eating more chocolate causes you to be more successful as a Nobel Prize person. I don't know. Anyway, so that's what we're comparing, and we're going to do that down here. So I've copied this data. So everybody go to example 2. I've copied this data right here into this table, and we're going to do this formula here. So if you need to pause to write this down, I shouldn't put an X here. I should put a dot here because that means multiplication, right? And there's a lot of X's going on and stuff. So that's a dot, that's multiplication. So we have this table, and we're going to fill in all of this stuff, okay? All right, so here we go. Let's jump right in. I'm going to get my ugly calculator out here. First thing we want to do is, if these are all the X's and these are all the Y's, I want to add all of these up to get the sum of all the X's. That's what this little symbol means, is that the sum. So I want the sum of all the X's. So 5 and 6 and 4 and 4 and 5. And that I get is 24 if I add them together, okay? Part of this warning, I'm going to have you guys calculate this like finally on your own and get an answer that's part of your homework assignment, so make sure you're following along because I will make you at some point, my phone calculator is going to give out, so at some point I'm going to set you free and make you calculate the rest on your own. Okay, let me check to make sure that that's right. Yep, no, wait, 32 is what I got the second time. 15 plus 5 plus 11. Nope, 31. Okay, so the sum of all the X's, sum of all the Y's I got was 24 and 31. Okay, in here, they're going to make me calculate the X squared values. So I'm just taking all these guys and I'm squaring them and I'm putting them over here. Okay, so like 5 squared is 25, 6 squared is 36. This is 16 and 25 again. And then we're going to add those all up. 25, 36, 16, 16, 25. I got 118, I believe. Yep. All right, squaring the Y's is taking these guys and squaring them. So 36, 81, 9, 4, and 121 is what those guys are. Is 251. Let me check that again. We don't want to screw something up, otherwise everything will just snowball from there. Ah. Okay, 251. All right, now the last column, they want me to take X times Y. So I'm multiplying these together. So that first one is 30. Okay, 6 times 9 is 54. This is 12. This is 8. This is 55. And now I'm going to add that column up. And now we're going to plug into our calculator and get a number. I got 159 for that. Let me check that again. Yep, 159. All right, so now I have all my stuff, and now I'm going to use this first formula to plug stuff in. All right, so here's the deal. N. Let me plug that in for N. N is the number of pairs of data that I have. So I have 5 X's and 5 Y's. So I'm going to put 5 in there for N, okay? This number is the sum of all the XY's. Sum of all the XY's is this 159 right here, okay? Minus the sum of all the X's comes from here. This is 24. And then I have the sum of all the Y's, which is 31. Okay, so like already that doesn't look terrible too much. Like we've had worse in the past, right? And then on the bottom, I have this, the N, which is 5, times the sum of the X squared values. Now, pay attention to this. This is sum of X squareds, and this is the sum of all the X's squared. Okay, so pay attention to where the square is. Here, I want the X squared values, which is these guys right here. This is 118, okay? And the difference between that and this one is here's the sum of the X's, which is 24, and I'm going to take that value and square it. Okay, so the square comes after I look at that thing. And then times, I have the square root of 5, and the sum of the Y squareds, which is 251. That's what he is. And then minus the sum of the Y's, which is 31 squared. Okay, all right. I'm going to do part of this with you, and then I'm going to set you free, and that's going to be part of your homework, and then I'll tell you what else to do, and we'll be good to go, okay? So here we go. 5 times 159 is 795 minus 24 times 31 is 744. This is a lot of work that goes into play to finding this R, and I realize that. I apologize, kind of. All right. 5 times 118 is 590 minus 24 squared, 576. So if I subtract those, I get 14, okay? And this guy right here, 5 times 251 is 1255 minus 31 squared. That's not right. Is 961. Okay, that's 294. All right, so I got it to this point. So what I want you to do is go ahead and finish this out and find what that R value is. And then we'll talk about whether it's a good R or a bad R or a positive R or a negative R. We'll talk about what that is tomorrow, okay? And then we'll calculate the other method as well. Go ahead and finish that out, find out what that R value is. For homework, what I want you to do is to, let me go to my other page here. I want you to do number 1, number 2, number 3, where you're matching and doing all those things. You're not actually having to calculate anything like what we just did. We'll do that later on. But 1, 2, and 3 are just asking some of the questions about R. And so the hard work will come later. So those should be fairly easy. Do those for homework, and we should be good to go.